Videos we have seen how pKa values helps in predicting the acidity or the acidic strength of the a species. So bigger pKa value means a weaker acid, and a smaller pKa value means a stronger acid, as shown here. So this is what I'm talking about. Okay, now let's see how we can use the pKa tables. They're very easily available in all the standard textbooks. We'll use them to predict that of the two species, which one will act as an acid or a base. So suppose you have been given two species, say there's a reaction, suppose like you have a species like this, which is basically phenol, and you have an alcohol, say ethanol. Now in both the cases there is a proton which is attached to oxygen. Now which one out of them will act as an acid and which will act as a base? So to predict that, the first method, which is the pKa, like quantifying that, we'll use that. The pKa of phenol from the standard tables, I'm writing the value of the pKa for phenol is 9.9, while the pKa for ethanol is 16. So this is ethanol or ethyl alcohol. So you can see that of these two, phenol has a lower value of pKa, which implies that it is a stronger acid as compared to ethanol, which means now we can predict the reaction, the course of reaction, that who will act as an acid and who will act as a base. Fine. So the reaction would take place where phenol will act as an acid. So phenol will give its protons and become phenoxidone, while ethanol would get, so I'm writing it down here. So the next product would be CH3, CH2, and then, so this is oxonium ion. Fine. So this equilibrium will be more towards the product side. Okay. And phenol will be acting as an acid because its pKa value is lower as compared to ethanol. So this is how. Another example which we started with in the previous videos is that of the ammonia and water. Like you have ammonia, which has so many protons attached to nitrogen, and you have water where you have two protons attached to oxygen. Now to predict which one of them will act as an acid or which one will act as a base, so their pKa values, for ammonia it is 38, for water it is 14. So water will act as an acid because its pKa value is less. Sorry. So this will act as an acid and this will act as a base, and this way we can predict the reaction. Fine. So pKa tables helps us a lot in all this. Not only this, pKa values also helps us in predicting the or comparing the basic strength, comparing the basicity using the pKa tables. Basic strength using pKa tables or pKa values. How do we do that? So to see that, one thing which we should know, that whenever a strong, like if the out of the two species one is a strong acid, it would have a weaker base. Okay, so of the two, the strongest acid will yield weakest conjugate base. Weakest conjugate base. Okay, that is one. Or the weakest acid will have the strongest conjugate base. So there's an inverse relation between the two. Now suppose someone asks you this question, like of say hydroxide ion, OH negative, and SH negative ion, which one is the weaker base? Which is a weaker base or which one is a stronger base? Now to predict this, you can use the pKa values. Now the pKa value for their conjugate for their conjugate acids. So the conjugate acid for this is water. Its pKa value is 14. For the pKa value for the conjugate acid of this, which is H2S, so its pKa value is close to the range of 7. I believe, yeah, it is 7. pKa is 7, which implies excuse which implies that this is a stronger acid, the one which is highlighted in blue. So H2S is a stronger acid as compared to water of these two. So if H2S is a stronger acid, so its conjugate base would be the weakest one. So this is the weaker base as compared to the OH negative. So this is how you predict the things. I repeat, stronger the acid is, the weaker its conjugate base would be. So if you are asked to pick which one of them is a stronger or a weaker base, write down their respective conjugate acids, compare their pKa values, and after comparing, predict which is a stronger acid. So whichever is a stronger acid, that would give you the weakest base of the two. Okay, this is how you can predict.